So to solve a quadratic means to find what? Close. Find the x-intercept, right? And the other words for x-intercept were zeros, or solution, or the roots. Yeah, like there was a lot of different terms, but at the end of the day, you're looking for x-intercepts. Things that'll make an equation equal 0. So the very first thing you always do is write your form into general form. This is general form right here. ax squared plus bx plus c equals 0. That's general form. So your first step is always change your form to general form if it's a quadratic. Once you've done that, what's the first way to try to solve these things? Not quite. I think you're on the right track, but you got the wrong word. Yeah. Factor. Always try to factor first. So if you could factor something, then you can use that zero product property, right? Like something times something equals 0. You can't factor this. So if you try to find things that multiply to be -4 and add to be -2, it's not possible. We're doing B, by the way. The other one's we're just reviewing. If you can't factor, you need a new way to solve quadratics. That new way was called the box method. The box method will always work for every question. So that's kind of nice. The first thing you do with the box method is you draw a beautiful box. This box essentially represents an area diagram. And we're going to try to create two binomials on the outside of this area diagram that are identical, that create this quadratic that we have right here. Hello, Miss Bell. How are you? Yeah, for sure. We're going to pause. I'm going to pause. See you. We know when we're doing these things that the first term of our trinomial comes from the first box of an area diagram, right? So this x squared term, it comes into this first box. And the outsides, we need two things that are the same that would create x squared. X and x. They would create x squared. The next step is to look at your b term. And we know that the b term comes from the two diagonals. Right here, right here. And we want those to be the same. So what two numbers that are the same could go into those two boxes that create -2x? Yeah, -x and -x. Right? If you had two of those, add them together, that's -2x. Right? It's like an area diagram that you're just creating. That means my outside edge has to be -1 and -1. And you see we created two binomials that are the exact same, x minus 1 and x minus 1. The last box of the area diagram. What would that equal? It equals positive. Okay? And we get that just by calculating -1 times -1 is positive. The problem is, if this quadratic doesn't match up with the box we just created, the C value will always be wrong. Okay? If it's not wrong, that's awesome news. It just means that you had a thing you could have factored. That's all it means. 99% of the time, if you're doing box method, you will have a C value that does not match the C value in your box. So what we need to do is somehow make this -4 equal to this +1. What would we add to that -4? What's 5? If you added 5 to this quadratic, then you would actually have what we created in the box. If you add 5 to one side, you have to add 5 to the other side, so over here. What we just did was we took this quadratic, x squared minus 2x minus 4, and we changed it to equal x minus 1 squared. And it used to be equal to 0, but now it's equal to 5. So we took a quadratic that was unfactorable, we turned it into two binomials that were the same thing. Everyone remembering that? If you weren't here, you might be like, whoa. The reason we did this is we created a scenario we can actually solve. When you have something squared equals a number, what can you do to get rid of the square? You square root both sides. When you square root both sides, you have to do something in front of that square root sign. What's that something you have to do in front of it? Plus minus, exactly. Remember, anytime you square root something, you put a positive and a negative symbol. The reason being is if you took your answer and put it back in here, when you square a negative number, it becomes positive. Anyway, what's my last step going to be? Add one to both sides. So x should equal 1 plus or minus root 5. That would be my solution. We would leave it like that. Okay? You wouldn't change it to a decimal. We don't use decimals. Unless it's like 2.5, we don't use decimals. That's what we did before the weekend. Anybody have any questions about that? That was a perfect time to try to solve it because 1, it's about to get harder, and 2, I need to drink water, so you can talk for a little bit, ask a question. No questions about any of that? Alright, today it's going to get a little bit harder. The reason it's going to get a little bit harder is all the examples we did before. If you look at them, the b value is always an even number. And so because it was an even number, it was easy to split it into the two diagonals. See how we had negative 2x, easily split between negative x and negative x. When it becomes an odd number, you can't evenly split it. Which is what's going to be something that makes it a little trickier. No, because you always have to make the same binomial. Otherwise, you couldn't have the same binomial squared, right? This is always our goal. You could do it with decimals, and we used to do it with decimals. The problem is the decimals get very hard. And you'll start having things like the square root of 3 underneath a radical. Like, it gets very messy really quick. So we're going to go with a couple tricks to help ourselves. Remember, we always try to make hard things easy in this class, and that's what we're going to do. So if you look at this question, you see you have x squared minus 3x plus 1. I don't want you to write down what I'm about to write down. The first strategy is always to hit general form. Equal to 0, we've done. Then we try to factor it. We can't factor it. Then we try to box method this. I'm going to box method, I'm going to fail. I'm going to show you why it fails. So don't write this down or you're going to run out of space. I know my first term goes there, and this is why I fail. So I go to create my two corner terms. Right? My negative 3 always comes from my two diagonals. And I need two numbers that are the same that add to be negative 3. So that's when you start getting into negative 1.5 x's. And if you do that, then you have negative 1.5 here, negative 1.5 here. That means this number in here is going to be even worse. So negative 1.5 times negative 1.5 would be 9 over 4. So you're going to have 2.25. And then you're going to have to figure out what number do I add to get 2.25. And then you're going to square root 2.25. And it's going to get really, really messy and really, really ugly. So you immediately see that you can't split that evenly or nicely. I guess you can split it, just not nicely. So you come up with a new plan. Your new plan is that you're going to change this negative 3 to become an even number. Because we can do that. And we can do that through multiplication. Now, most people, or like if I want to multiply negative 3 to become an even number, I multiply it by 2. And that's easy, right? 3 times 2 is 6, and you're good. So, I'm going to show you why 2 doesn't work. Because that's going to create a whole new problem for us. If I multiply everything by 2, my new quadratic would be 2x squared minus 6x plus 2 equals 0. And if I go to do a box, please don't do this. If I go to do a box, my first term always comes from my first box. I need two things that are the same that multiply together to be 2x squared.
So we should be able to do this one in 4.
Yeah, you're going to realize right now you can't. You can't multiply two things to equal 2. That's your problem. So you have to have an even middle number and a perfect square first number. So what would be a good number to use, Jackson? 4 would be the perfect number to use. So when we go to multiply things, we always are multiplying with two goals in mind. The first goal is make the middle value even, make the first value a perfect square number. So in this case, if I multiply everything by 4, it'll give me exactly what I want. It'll give me an even middle number, a b value, and it'll give me a perfect square a value. You can see how this gets a little harder, right? The numbers were always conveniently picked before this. Once you've done that, your box method is identical. Nothing changes to it. It might get a little trickier at times, but it's still the same concept. So the concept is you're creating some sort of area diagram to make that quadratic. The first term always comes from the first box. I need two things multiplied together to become 4x squared. So I'm going to put 2x and 2x. My middle terms, so negative 12x. That creates my diagonals on my box. I need two numbers that are the same that would add to be negative 12. Yeah, negative 6 and negative 6. Now, before this, on the outside, that just meant the outsides were negative 6 and negative 6. But you're going to have to use a little bit of intuition to figure out that the outside of this box is not going to be negative 6. Because this is an area diagram, right? So it's 2x times something equals negative 6x. So the outside is actually going to be negative 3. Right? 2 times negative 3 creates negative 6. So the outsides are negative 3 and negative 3, not negative 6 and negative 6. Because that wouldn't have created what we wanted on the inside. Now that you've done everything in your box, you can determine what the last term should be. Negative 3 times negative 3 should be positive. And you have to ask yourself, how can I get from positive 4 to positive 9? I need to add 5 to both sides. That gives me 2x minus 3 squared equals 5. Any questions? The next step's coming.
Next step, we're adding, we have the 2 in front of the x. We have the plus the other one, but if you get the 2x, it's plus and minus.
So just like formatting. Okay. So he's just moved ahead. He solved this thing. So we would square root both sides, correct? So that would give us 2x minus 3 equals plus or minus root 5. Then we move the 3 over. So I have 2x equals 3 plus or minus root 5. And the question is now, how do you get rid of that 2? Like when you divide it, what does that look like? Because everyone here should know I need to divide by 2. When we divide by 2, we write it like this. X equals 3 plus or minus root 5 all divided by 2. And that's how it looks. Make sense? Any questions? We'll do a few more together. All right, let's try to be together. And I apologize, I really run out of room on this. I'll try my best to try to keep it all somewhat together. All right. I have a quadratic. The question is to solve the quadratic. What's the best way to solve a quadratic? Factoring. Factoring is always the best way to solve a quadratic. Always the easiest. You can see how hard these box method questions are going to be getting, right? So if you can factor, factor. Don't forget that. I'm going to keep trying to remind you because people get into this habit of like, you learn something really hard and complex like box method, and now you always try to show that you know something hard and complex like box method. When reality is, most of the time you can factor it and it'll work. Sometimes you can't. That's when we box method. Okay? So the box method, you have to be in general form, which we are. You have to have an even b value. We do not have an even b value. You also have to have a perfect square a value. We do not have a perfect square a value once we multiply by 2, but we could multiply by...
Should we always just multiply by 2?
Not always. Sometimes you're going to have to multiply by a couple things. Sometimes you only have to multiply by a smaller number. It depends. And we will run into a few situations where you don't. But 99% of the time, multiply by 4 and you're safe. So if I multiply everything by 4, it becomes 4x squared minus 20x plus 12 equals 0. And you hit your goal of perfect square a value, even b value. Now you can do your box. So if I write out my little box, my first box is 4x squared. The way I create 4x squared is by having 2x and 2x on the other sides. I then know that my b value comes from my diagonals. So if I want negative 20x, that means I'm going to have negative 10x and negative 10x. That means the outsides had to be negative 5 and negative 5. Once you've solved the outsides, you can figure out what your last term should have been. It should have been 25. In reality, it was positive 12. So you need to turn that positive 12 into a positive 25 by adding 13 to both sides. This turns your original quadratic into 2x minus 5 squared equals 13. Any questions on creating the box? People get pretty good at that. It's then solving this thing where we make a lot of mistakes. So, if you're good at making the box, remember you need to square root both sides. When you do that, please don't forget the plus minus sign. You then need to add 5 before you can divide by 2. And your final step is divide it all by 2. So you get x equals 5 plus or minus root 13 divided by 2. Those are the solutions to that quadratic. They are what would make that quadratic equal 0.
Are we ever gonna get it where it's like it's x squared in the beginning? Are we ever gonna get it where it's x cubed at all?
No, that'll be next year. So x cubed will be primarily next year. Yeah, so you're safe. All right. If you look at C, and you went to do box method on that thing, that's a situation where you could just times by 2. Because then you have a perfect square A value and an even B value. So that is a situation where it could work to multiply by just 2. But, has anyone tried it? Yeah, what's the problem you run into when you do that one? Yeah, so don't write this down. I'm going to show you what you run into in this situation. So sometimes you're going to do box method. You're going to multiply everything by 2. Please don't write this down. When you go to do your box, and you do the first term and you're like, excellent, it's working out. And then you know you need negative 5x and negative 5x. And the problem is, what times 2 equals negative 5? And it's not a nice number anymore. So that would have to be negative 2.5. And then when you start doing decimals or fractions, it gets harder and harder and harder, and it snowballs on you. Right? Because then you're trying to figure out things that add to decimals, and it's really, really, really not nice. If you run into that situation where it no longer works, then you need to go back to this original thing. It's right here. And you multiplied by 2, and it worked, and that was nice. And then you need to multiply it by 4 again. So sometimes multiply by 2 will work, and then if it doesn't, you multiply by 4 again. So if you ever talk to Ms. Chavez, you rip a 4 through it. That's the terminology she uses. But you would just have to multiply by 4 again, because that'll create 16 here, which is a perfect square number, and it'll create an even number there, which will be able to divide by 4. Yeah, same thing. So if you know to multiply by 8, that also works. Hey, so, yeah, give me 2 seconds though. Because we looked at this question, we had to solve it, and we just saw the disaster that is the box method. Correct? Alright, what's the easiest way to solve a question like this? Okay. Factor it. That's a factorable question. So if you got this question and it said solve and you started doing box method, you see how hard it would have got. It would have got very hard. That's factorable. So don't forget to try factoring first. That's always your go-to. Right? Try factor. Now you can do easy. Thank you. So if I go to factor that thing, that means I'm doing a diamond. On the top of the diamond is 6, the bottom is negative 5, negative 2, and negative 3 would multiply to be 6 and add to be negative 5. So you're always looking to factor first. Save yourself from all the pain and sorrow that is box method. When you do that, that means you have 2x minus 2 and 2x minus 3 equals 0. Right, the 2x and the 2x, because we know we somehow had to create 2x squared. And then the sides of the diamond join each binomial. We know we don't want to have 2x into both of them, so we try to divide one of them by 2. Which one can divide by 2? The first one. And that creates your final answer of x minus 1, 2x minus 3 equals 0. That's not your final answer, that's your final factored form. The reason you factored is now you can use zero product property to solve this. So what values of x would make each set of binomials equal 0? X equals positive 1 would make the first set of brackets equal 0. The second set of brackets would not be 3, it would be 3 divided by 2. Remember, if you're not sure, you can always go and on the side, you can say 2x minus 3 equals 0. That means 2x equals 3, and that means x equals 0. So you can always solve it on a side piece of paper if you needed to. Or if you get good, you'll start to catch onto a pattern that it's always, not always, usually, this number divided by this number. Usually, not always. If you had, sometimes the negatives throw people off. So if this had been negative 2x plus 3 or something like that, then it might be people miss the negative part, and so they divide by not a negative number, and that's what this is. See why we factor? That box method question was going to be very painful otherwise. Yeah. All right, we'll do one more together. So we look at D. If I go to box method that thing, what's the first problem I'm going to run into? The first problem is that it's not in the correct format. The format it needs to be in is general form. That thing is not general form. So I need to move that 7 to the other side so that it's equal to 0. But remember, you gotta be in general form to do any of these questions. So my actual question should look like this. Now, what should I try? Try to factor. Try. You can't, right? Things that multiply to be negative 7 added to positive 7 don't exist. Now what do I do, Jackson? Now I times everything by 4. Why am I timesing it by 4? Because this middle value is odd, right? You can't box method middle values that are odd. You can, it's just odd. So you're going to multiply everything by 4. That gives me 4x squared plus 28x minus 28 equals 0. Now I want you to try to create the box. So don't worry about solving it. See if you can create the box properly, the inside and the outsides of it. So I'm going to give you a second just to think, try it on your own, then we'll do it together so that you can compare. Your goal should have been to try to create that box. So let's do it together just to see if you did the right thing. Hopefully your box looks like a box. Step 1. Bad joke. It'll work. Okay, the first box has to be your first term. That's my 4x squared. To create 4x squared, it should have been 2x and 2x. Then I look at my middle term. I have a 28x. I need to split that evenly to become 14x and 14x. I then look at the outside to be like, what numbers could go on the outside that would multiply to be 14x? My answer is 7 and 7. That creates my final spot, 49, which is nowhere close to 20. So, you should be checking to see if your box is correct. Once your box is correct, you need to make your quadratic actually equal to what the box says it should be equal to. You add 77. You were correct. How'd you get 77? Yeah, you went 49 plus 28. That works too. Yeah. So I would normally go 49 minus whatever number is here. So 49 minus negative 28 would tell you the same thing as just adding 28. You have to add 77 to both sides. Awesome. When we add 77 to both sides, we now have this. The outsides of the box squared equals 77. I want you to try to solve that thing and write it in the form that you would see on a test. So go ahead, try to write the answer to that thing. Solve this thing. I'm going to square root both sides. That should be 2x plus 7 equals positive or negative root 77. Check to see if you put positive or negative root 27. It's got to be both. Okay? You have two answers to this question, not one. I'm then going to subtract 7 and then divide by 2. So my answer would look like this. That's the answer you should have got. If you reversed the positive negative root 77 and the negative 7, that works too. So if your answer looks like this, that's also okay, but you'll normally see it written the way I have it right now, where the constant goes in front. Normally you would have the plus or minus come later on. Both are technically correct. Alright, the last one that we're going to do together. I look at that thing, it has to be in general form. Before I even put it in general form, there's something I don't like about that question. I hate fractions. So I'm going to multiply everything by 4 to get rid of the fractions. And that'll turn that question into 4x squared plus 4x equals 3. So I multiplied everything by 4. And that gets rid of the fraction for you. Then, like Jackson said, you have to be in general form. The question says solve it. So I want you to try from here to the very end. Try to go all the way through, and then we will do it together and try to solve that. So go ahead, give it a shot. The question was solve that. You can box method it. You can also factor it. So neither answer is wrong. They'll both give you the same answer. That's why it's like box method works for everything. Even if it was factorable, it works for everything. So either works. Yeah. I honestly, like with the numbers that you're working with, you should be able to check the diamond pretty quick. So that's what I would do. Every question, if it says solve, I would check and try to do diamonds. That'd be my instinct. And if it doesn't work, like if I can't immediately figure it out, then I just give up and go to box. Because you're not wrong, right? Like you got the same answer I'm gonna get. You just did box. So you're not wrong. It's just different method. You guys typically are better at factoring, which is why we encourage factoring more than box. You have negative 12 on the top, 4 on the bottom. That's 6 and negative 2. That means you should get 4x plus 6 and 4x minus 2. Neither of those are divisible by 4. So what do you do, Jenica? You divide both of them by 2. Two things that would multiply to be 4. And that gives you 2x plus 3, 2x minus 1. Your answer should have been the same for both. You should have got negative 3 over 2, or you should have got 1 over 2. So whether you use box method or factoring, you should have got the same answers. You might have got this using box method. You might have got 1 plus or minus, sorry, negative 1 plus or minus 2 divided by 2. Correct?
Yeah.
So you might have got that as your answer. Notice that there's no radical in that answer. So if there's no radical and there's no decimal, that means you can actually calculate what the answer is. If I go negative 1 plus 2, that's 1, and divided by 2. So 1 divided by 2 is one answer. Negative 1 minus 2 is negative 3. Negative 3 divided by 2 is less than 2. So if there's no radical, you can actually solve both cases. Yeah, Karen? Using the diamond method in blue or in the red? So I look here, and I wanted to make each of those equal to 0. So the first one I said, okay, what makes 2x plus 3 equals 0? And I subtract 3 from both sides. Do that, and then I divide by 2. And then I did the same thing for the second one. I would go 2x minus 1 equals 0. I would add 1 divided by 2. The pattern of this number divided by this number works, but it's always the opposite symbol. Because you have to add or subtract to those. How many people factored that thing? 2, 3, 4, 5. That's not bad. More caught it than not, maybe because I just done one before where you had to factor it. But just remember, you can check factoring before box method. How many people box methoded it and still got their answer? It's pretty good. It's not bad. You're better at factoring than box method. Trust me. Like, as somebody who's seen you do a lot of both, you're better at factoring. So if you can factor, factor. These ones, level 5. It actually does get harder because we're better than making video games than people making video games. So, the first question you look at, what's your first step? It has to be in general form. You have to be in general form. Now, technically, for box method, you don't have to be in general form, but don't tell anyone I told you that. So, always go into general form. You're going to subtract 7 from both sides to get 3x squared plus 2x minus 1 equals 0. So right here, I would factor. Remember, try to factor first. You might be able to, you might not be able to. But the question isn't do box method. The question is solve, right? That's what all these questions have been. So you're going to try to box or diamond method. You want something that multiplies to be negative 3 and adds to be 2. 3 and negative 1 would work. So if you can diamond method, you're better at diamond method. Always go that route first. So you'd have 3x plus 3 is 3x minus 1 equals 0. Divide one of them by 3. You get x plus 1, 3x minus 1 equals 0. X equals negative 1 and 1 over 3. You could have box methoded it as well, and it would have worked. Yeah. So that was Jackson's. That's what you asked, right? By 2. So, Xander, why would you multiply? If you were doing box method, why would you multiply by 3? It makes that a perfect square number. Makes it 9. Still makes that an even number. Makes it 6. So multiplying by 3 would be the right answer if you're doing box method. If you multiply by 2, that gives you 6, which is not a perfect square number. And you want that a value to be a perfect square number. Again, try your best to always use diamond method first. Makes your life much easier. I'm just going to slide C out of the way here for a second. I'm going to do B. So let's try it again. To do B, you have to be in what? General form. You have to be equal to 0. You're going to end up with, draw a line here to break this up a little bit. You're going to end up with 3x squared plus 2x plus going to dimensions of that. And I can't. Right? So if I go 3 times 1, things that multiply to 3 add to be 2, doesn't work. That's when I'm going to start to use my box method, after I failed at using my diamond method. We're going to use Xander's same trick. Okay? If I multiplied by 2, that would not create a perfect square A value. And you have to have a perfect square A value. So instead, I'm going to multiply everything by 3. And it's still achieving both my goals. I want a perfect square A value. I want an even B value. Now, multiplying by 3 and getting an even and a perfect square does not guarantee it's going to work. It gives us a very high probability of working, but it doesn't guarantee it, okay? So you still might fail here when you go to create your box. You might run into those decimal problems. If we do, when we go to create our box, we have 9x squared in the first box, that's 3x and 3x. We have 3x in each corner. And we try to create outsides that work for that, and it actually works, so that's perfect. If it hadn't worked, we would just go back to our other step and multiply by 4. But this one does work. I can go +1 and +1 on each of my sides. Yeah.
So if it doesn't work decimal sides, do you always go back to like by 4, or do you change it to negative?
You always go back and multiply by 4, and it should always work. Sorry, I put this +1. I just typed it. Yeah, for sure. You then look at your original quadratic. You try to figure out what you have to add to get to our new quadratic. We have to add -2. So subtract 2. Yeah, so you have to subtract 2 from both sides. It's better than saying add -2. That gives me 3x plus 1 squared equals -2. Dot, dot, dot. See, it's why video games are fun. How can I solve that thing? What do I have to do to both sides? How do I get rid of the square root? How do I get rid of the square? Square root both sides. Why am I in trouble? Because you can't square root a negative. No solution. Perfect. So if you get to here and you square root a negative, that means there is no solution to this problem. And people always go, what does it mean you have no solution? How is it possible to have no answer? That doesn't make sense. These answers represent x-intercepts. So when you say no solution, you're saying there's no x-intercepts. You have a graph that doesn't cross the x-axis. It could look like a lot of things. It could look like this. It could look like this. Right? So it doesn't always have to have an x-intercept. And that's what you're proving by doing that box method. Yeah. Not this unit, next unit. So unit 2 is all about solving quadratics. Unit 3 is about analyzing quadratics. That's where we'll do word problems and graphing. And we do word problems in this one, but we do more in unit 3. Okay. We're going to skip C, mainly because we're going to run out of time. And it's an easier one. To do C, I have to get rid of the decimal. To get rid of a 0.5, I have to multiply by 2. And in this case, I'd have to multiply by -2, because you want A to be a positive value. Right? You always want it to be +1. And if you do multiply by -2, it just creates an easier box method question. There's no other tricks outside of that. What I do want to do is D, because D is a nightmare. And the best way to end class is to see you all cry. So that's why we want to do that together. It's extra. You'll see. Okay, we'll do D together. We'll leave E for you to do it at home when you're trying to have fun. Alright. D. What's the first step? General form. Always general form. So you're going to subtract 8 from both sides. You get 7x squared minus x minus 7 equals 0. And yeah, so for this one, you want a perfect square a value, correct? So multiply everything by 7. So it's going to create some big numbers. You're going to get 7x squared minus 7x, sorry, I said before. And then minus 49 equals 0. And that's great. You got a perfect square a value. That's fantastic. Why? Yeah. If you look at this thing, you got a perfect square a value, and that's fantastic. The problem is you have an odd b value. So you have to get rid of that odd b value. And when you multiply, that means you have to multiply by an even number that's a square number. So the smallest even square number we know is 4. That's why we choose to multiply everything by 4. If you multiplied everything by 2, you wouldn't have a perfect square a value. So you multiply everything by 4. And this is going to be some huge numbers. 196 minus 28x minus 196 equals 0. Pardon? No, we're not going to reduce that because then you would just get back to the same problem you had before if you try to GCF. Now we are going to run into another problem. So this looks fantastic. We have a perfect square a value, correct? And we have a b value that's even, which is nice for us. So then we go to do our box. And when we go to do our box, we have 196, that should be next. That's 13x and 13x. So by multiplying by 4, it will create a perfect square number. It might be a crazy one, but it is. 14? My bad, that's 169, it's x squared, right? Yeah, there's no video game with 196, so I don't know. It's a race. Actually, that saves us our problems. That's good news. Then we take our negative 28 and we break it into 2 to be negative 14x and negative 14x. See, if it was 13 on the outside, that would have been really bad. You weren't going to get that to be 14. What numbers must go on the outside to get our negative 14s? Negative 1 and negative 1. And that creates positive 1. That means the number that you have to add is 197, both sides. You now have 14x minus 1 squared equals 197. Once you get to this stage, if you can get here, it's all the same. Right? You're going to square roots, add or subtract, and then divide. It'll always be the same. But you can see how these boxes get a little bit more complex the deeper into it you go. You always need a perfect square a value, and you always need an even b value. That's always your goal. Your final answer for this would be 14x minus 1 equals the root of 197 plus or minus in front. Then you're going to add 1 and divide by 14. So you have 1 plus or minus root 197 divided by 14. You should look at that answer and try to simplify that radical as well. So if the root 197 can be simplified, you should simplify it. I don't think it can. Yeah, it's 1 off. So I'm very confident you can't divide it by 9 or any of those other perfect squares. If you can, so be it. We're just not going to do it. Okay, we're not going to do E. If you want to